Good. So, well, I gave you a bunch of tips and tricks on how to fix problems with data sheets that you got by others and that were not in the right format. And we'll do more of that in the lab. But I also want to give you a sense of what you can do in R as an example if you actually design things from scratch. So if we go back to our first little sample experiment that we put out here, we had 3 sides, 1, 2, and the third one got erased there. We have 3 treatments, A, B, and C, and we have 3 replications. You have this treatment 3 times and it's randomized within the site. So I can design a data table, and let's say this is a big forest, let's pretend this is a big forestry trial, and you actually want to walk through this and then turn around and go back. So I show you how you can set up these files, and if this is an experiment with 6,000 trees, that can be a bit of a pain. I mean, you can do it with copy and paste in Excel, but there are better ways. So I'm just going to demonstrate to you how this works in R. So let's fire up R, and I actually already prepared a little program here so that you don't have to watch me type. This is actually not an example from the lab, but I just want to give you a taste of the power of the tools that you have in R. So one useful little command is this expand grid function here. So what you can do is we give your design parameters. So you have 3 sites, S1, S2, S3. We said we have 3 treatments, A, B, C, and 3 replications. And if you execute this, so let's run this. I run this with Control R. You can have it all in 1 line, but I put it in 3 lines so that you can better see how this command works. And we look at the results. You see we have already a nice data entry sheet here with 27 rows, 3 by 3 by 3. So that's good. Now we do want to randomize our treatments within sites. So what I'm going to do, because I don't really need the replication column, I replace this with just a random number here with 27 random numbers. So let's execute this. And then I'm going to sort this by that random number, but also by site, because I don't want this site mixed up. So I want to randomize within sites. So whatever you want to randomize within, you put that first in your order or sort statement. So let's run this as well and look at the results. And you can see now we have a proper randomized experimental design. These are the old, this is the old order, this column here is the new order, and our treatments are now randomized. This rep column is actually not something that we need. That was just to allow randomization by sorting by that random number. Okay, now we do also want to add an order now, which we can do. So I'm just going to create another, let me close this. I'm creating another variable that's called order from 1 to 27, and I create an ID. And rather than typing this in Excel, so we can use a paste command here. So that just pastes the site, the treatment, and the order, and I'm going to separate each of those by a little dash. So let's run this as well, and we can look at it again, and there it is. So we are done. Rather than cleaning that up here, I'm going to clean it up in Excel. So we're going to write this out, and we're done here in R. And what I showed you for this very tiny little experiment, I can do just as fast for an experiment that has 6,000 rows and complex block and incomplete block design. So all I need to do really is add more rows here for, let's say, blocks, or more treatment levels for more treatments. So I just add D, E, F, G, or whatever your treatments are. You can have more replications, so you can design gigantic data sheets that way very quickly. So if you open this file that we just exported out of R in Excel, this is how it looks. And we can clean this up a little bit. We don't actually need that replication column here, so I'll just get rid of that. We also don't need the old order, so that's gone. And I like to put the order and the ID into the front. I'm just going to insert this here. And now I could use this if it's sorted by order as it is right now. This would be a data entry sheet. So I'm going to take my first measurement here, and I could enter it like as I go through the field, 12 and so on. Although since we said we start this from scratch, so we haven't actually even planted that trial. The first step would actually be to use this data sheet now to establish your trial. So you can just go through your site and plant that first type of tree, or apply this particular treatment here. And so that you don't have to watch me doing this, I actually created a slightly enhanced version of that same sheet here. So it's the same, but I just want to show you how you would go about establishing this. So you have your site, it's 3 by 3, or whatever the true dimensions of your big experiment would be, and you get the treatment order, the randomized treatment order. So you would just go ahead and, for that first plot, apply this first, we said harvesting treatment in our experiment. So this plot would be the first harvesting treatment. This would also be harvesting treatment A. This one would be harvesting treatment B. And then if I want to go back, so if I want this design where I can weave my way through that experiment, then your fourth one would be C, and that would come here. So you define the order by establishing it, and then you can use that order later to efficiently collect your data. That would work for any type of experiment that you actually design, that you put out. Now, if you have a sampling design where the example that I showed earlier is where you have a trail and and you don't really have control over where that trail goes first or how it's randomized even in the landscape, so you just pick sites that are randomized in the landscape, then you would have to enter that order manually. So you would have to see, okay, the trail starts at this particular plot and then continues to this particular plot, so you would give this a 2, and then the next one on that trail is this particular plot, and you give that a 3, and so on. So sometimes you have to do it manually, but many times you can use this R-created sheet to design or to put your experiment out and then to evaluate it efficiently. So I've given you a bit of an overview now on where we want to go with creating those standard data tables, why these are useful. And you also watched me struggle for a good 20 minutes with Excel to do some of the things like combine different columns into an ID, or separate columns of treatment combination. So you can do Excel, much of this in Excel. But you've also watched me 2 minutes accomplish something rather impressive with R in creating this data entry sheet and experimental design template to lay out your trials. So it's a good skill to have. If you get hired into a junior government position, or you get a job with a forestry company, or some sort of research assistant position, that's typically the first kind of job that lands on your plate. You're usually, as a graduate, you are a level up from just entering data, but you get those data entry sheets, and the task usually is, combine this into something that can be analyzed, and usually they will be very apologetic about it and say, I know this is super boring stuff, takes a ton of time, it's very repetitive, so we're sorry, this is how your first month is likely going to look like. So if you take that away and you come back the next day and it's done, you're on track for a pay raise. And that really happened to graduates of this class and my students in my lab as well. So these are skills that are very impressive to people who don't know how to work with R. Now, we're going to take this step by step in the lab. So we're just past the introduction on how to work with the software, how to import data. And so there are a whole pile of small routines and functions that you can combine to accomplish relatively impressive things. So we're trying different functions out in R, and some of them you have seen me do in Excel already. So selecting rows and selecting columns, that's really not much different than just deleting the rows and columns that you don't want. Transformations, conditional transformations. So sometimes you run into problems where some site data was entered in centimeters and in another site in meters. So you have to fix these sort of things. Separating different treatments which were combined in one column. You see me do that in Excel, combining multiple columns into an ID. We've seen that. Merging data sets, that's an interesting one. So often you have a historic database and then there's somebody else who creates a new one, here maybe that blue one, but they don't match up. There is problems, and so putting those together in Excel for a large database, that's close to impossible, but it's a one-liner in R that's done within 10 seconds. And similarly, appending data sets, so if you have just two, that's fine. But oftentimes there's lots of repeat measurements, and people put out a new little file every month or every year for you to download, and then you have to append thousands of them. So again, this is something that you can do quite easily in R. You've seen me use the order command in R. Wide to long table conversion. So that's a typical hiccup. That's also, it's possible to do it in Excel, but it's hard. So perhaps somebody entered data for site 1 and then site 2 and then site 3 in separate columns. But you can't analyze the data like that, right? We've talked about this. So I need a separate column for the treatment that actually tells me site 1, site 2, site 3, and I have to copy all that information into the right format. But again, that's just a one-liner in R, and you can go the other way as well. So we're taking this step by step with a very simple example that's just 12 rows long, so you can see exactly what's happening. But whatever you learned there in principle for this tiny data set, you can apply to very big data sets as well. And that the lab is actually a selection of useful commands that I think are important to start with. As you move along, and maybe once you get into your own projects, you will find more useful commands in this cheat sheet. So I posted that R cheat sheet as well on the class website. So good luck with the lab.